Hello everyone, in this video I'll be solving the smallest divisor problem, and this problem is from Geek for Geeks, and it says given an integer array AR and an integer k where k is greater than or equals to array dot length. Okay, yeah, find the smallest positive integer divisor such that the sum of the ceiling values of each element in ARR divided by this divisor is less than or equals to k. Okay. Let me take you to the board and explain you what they are saying basically. 1 to 5 9, k is equals to 6. So they have given array ARRS 1 2 5 9 and k is equal to 6. And in the question they have given k will always be greater than or equals to array dot length. This one is very interesting, I will tell you later. So now we need to find smallest positive integer. Smallest positive integer which divided by this number. Let's say we choose smallest positive integer to be, let's say, 2. So if you choose 2, 1 by 2, which is basically 1 I'm taking, and we divided by 2, this will give us 0. Sorry, it will give 0.5, and ceiling value of that will give you 1. In mathematics, if any point value is there and some after point some value is there, so that will be uh, treated as next greater integer. So after 0.5, next greater integer is 1. So now let's take 2 by 2. 2 by 2 is 1. Seal value of 1 is 1 only because it does not have any point value. Now let's take 5. 5 by 2 is like 2.5. Seal value of this will be 3. Now let's take 9. 9 by 2 is 4.5, and seal value of this is 5. So if you sum these things, it will be 8 9 10. So if you see whatever operation they have said, like we need to take smallest positive number such that when we divide each element by that divisor, and when we take seal value of that, and if you sum up all this value has to be smaller than or equals to this k. But in this case, less than 6 is false, which means smaller than k is false. So 2 cannot be smallest positive integer which does this thing. So somehow we'll have to take, let's say now I'll be taking 5 and then explaining. If I take smallest positive integer to be 5, so if you divide 1 by 5, this will give you 0.2, and its seal value is 1, next greater element. If you take 2 by 5, it will be 0.4, and its seal value will be 1. If you take 5 by 5, this will give you 1, and seal value of 1 is 1 only. If you take 9, 9.5, this will be 1.8. Okay, seal value of this will come out to be 2. Now if you sum these things, 2 3 4 5, the value what we are getting is 5, which is less than 6 is true. So this can be a smallest positive integer. So I think you got problem statement. Now coming to this array dot length, why it is saying whatever k value they will give, that will be greater than or equal to array dot length, meaning when you try to divide all the values with some positive integer and seal value comes out to be 1 1 1 1, in that case, let's say if you're choosing 9, so in that case all the seal values will be 1 1 1. If you try to do by 9, you will get 1 1 1 4 times, so which is 4. So the minimum value has to be 4 or greater than 4, k's value. If you let's take k value they have given is 3, in that case you cannot solve the problem because if you take the maximum element and divide all the elements by that, you will get the length of the array. Basically this, after doing these things, you will get length of the array. But if k is less than length of the array, then we cannot solve the problem. That is the reason they're saying k is greater than equals to array dot length. Now I think you guys got what is the problem statement, and let's try to understand how do we solve this. So one method which can be solved is what we can do is we can take what is the smallest element in the array, which is 1, what is the greatest element in the array, which is 9. So we will take all the values like 1 2 3 up to so on till 8 9, all the values will take, and one by one we'll take one values and try to divide every element. Okay, and whichever first value that, see, if you try to divide it by 1, so your answer will be greater than key always. Okay, you can do that, whatever steps I've showed, you can do that. If you try to do by second, that will also be greater than in second we have done that, we have got 10, so it was greater than 6. So if you try to do in this way, so from the not possible answer to possible answers you'll get. Okay, so in that case you'll have to find the smallest, right? So wherever there is a transition from not possible to possible, so that integer will be choosing. In this case it is 5. So this is basically a linear what you're doing. So what we'll be doing, we're taking a for loop which will run from smallest value, which is, let's say, smallest val in LTL, smallest val to largest val. It will run from smallest val to largest val, and again one more for loop will come into picture, which will basically run from 0 to n minus 1, which is size of the array, n if we consider, and whatever value what I we are taking, we'll try to divide those values. We'll take one count variable which will be initialized to 0, and we'll do count plus equals to array of j divided by I will do. And since we know in case of I had solved like 2 by 5, that was giving 0.4 as answer, but in integer that will be 0 only. So how do we but its ceil value is actually 1, so how do we take care of that? So we can use ceil function, but I'll be using this thing, 2 modulo 5, which will give you 2. If modulo value, I mean remainder, we have apart from 0 any value we have, then we will increase the count by 1. So 0 we have, so 1 if you increase, that will be 1, so which is our answer. So I'll check here, if array of j modulo I, it has some value, so in that case count plus plus will do. Okay, so and you need to check like whichever count value, if that is smaller than equals to k, so that is the value smallest positive integer which you need to return. So you will do after this for loop is check basically. So you can do that, but what I'm trying to say is that this is a linear, I mean quadratic equations time complexity. We are using two for loops. So according to the question, so array of I will be 10 power 6. So minimum will be 1, maximum will be 10 power 6, and array size is 10 power 5. So this for loop will be executing for 10 power 6 times, and this for loop will be executing for 10 power 5 times, which is basically 10 power 11, which is way beyond than 10 power 8. And this solution will give you TLE. So we will try to optimize the solution. So how do we optimize this? So yeah, one thing you can think of is that since we are considering all these elements from 1 till the max elements, all elements we have here, okay, so we were going linearly one by one, so that was going TLE. So why can't we think of the binary solution which does the first for loop operation in log of max of array of I, meaning the largest element what you have, till that time only it will run. So and the second for loop was n square, so our time complexity will be n square log of max this thing. So this will come under 10 power 8 operation, and this is basically 10 power 6, right? So log of 10 power 6, it was 2, so n square, so not n square, it is n. So this will basically be less than 10 per rate. So this will run in 1 second. So we need to do a binary search basically. So I'll try to explain in the code how we will be doing binary search. So int left, that will be initialized to 1, int right. Why we are not initialized with 0? Because if you try to divide any number with 0, that is not possible. So we'll start with 1. And what r value will take first element, but we'll try to find the maximum element right from the array. So val arr, r will be max of r comma val. Okay, so we got the left and right range. Now we'll do a binary search. Binary search, how we'll do left less than equals to right, and we'll find the mid. It's a typical binary search. I think you guys know how to do it. So we found the middle, which is basically smallest number we can think of. So now we'll take int count. We'll take one function helper, or we can name it this way: find smallest divisor. Okay, we'll pass the array, we'll pass the mid. This mid is basically the smallest positive integer. So this function, what it will do is, I'll write here, this function will basically return the count of the operation what they have said. Operation meaning we'll have to divide all the array elements with mid, and we'll have to take the seal value, and we'll basically sum them up, and the whatever value we are getting will that will be in count. Okay, let me do that. Find, let me just copy vector int array int mid. We'll take one variable count, which will be first initially 0. We'll iterate through this vector. We will divide this value by smallest number in our case, but later we will come to know if it is smaller or not. So whatever division we have put in count, but let's say it is 2 by 5. So in that case it will be 0, but our answer will be 1. So we need to find 2 modulo 5 also. So for that I'll be doing val modulo mid. So if 2 modulo 5 is equals to 2, so it is basically greater than 0. So in that case, if that will come into this if loop, and we'll have to increase one count. Okay, and at the end we'll have to return the count. So now we got the count here from this function, find smallest divisor. Now we will have to compare. What we'll have to compare? If this count is in the question what they will find the smallest positive integer divisor such that sum of ceiling value of each element in here less than or equals to k. If this count is, let's say, greater than k, so in that case the mid value, I mean smallest positive integer whatever we have taken does not satisfy, meaning we'll have to move to the right side. So what I'll do is we'll move to the right side, so our left pointer will point to mid plus 1. Else if it is lesser than or equals to, which means we are finding some larger value from the right side, so it is giving us the smaller count. So we'll try to get the smallest positive integer. So now whatever we have, it is obviously correct, but we need to again find the smallest. So for that we'll move the right pointer to mid minus 1, and at the end we'll return lyl, because from the left side to right side whatever showed on the board that time, so it was like from left side it is not possible, but whenever I mean from right side it was possible. So right side will cross the left side, and left side will be pointing to a smallest positive integer which satisfies the given condition. So we need to return L. So let me try to run the code. Yeah, it is running fine. Second problem is 1111 and k is 4. Why is it not editing? Acha. 1 and k is 4. So let's try to test this case also. Yeah, it is also fine. Let's try to submit the code. It's a typical binary search solution, so it is not that hard. I think you enjoyed this video and got to know how to solve this. And yeah, if you analyze the time complexity, as I already said, key it will be this binary search is taking log of max element of the array, and this function find smallest divisor is taking O of n every time. So it will be n into log of max of array element, and space complexity we are not using any extra space, so it is O of 1. Let me see the expected what was. Okay, yeah, expected also matches here. Here it was n star log of max of array element, and space was 1. So yeah, thank you guys for watching the video.